Welcome back. I just want to do a couple more of these problems just so you, I guess, just see a couple more problems and get some practice. So let's start with another problem. As always, let me draw my triangle. I always like to draw a little different to confuse you. Let's say that this angle up here is 0.36 radians. That angle is 0.36 radians, and then this side right here, this top side, let me do it in a different color. This top side in pink is square root of 73 units long, or whatever. It could be inches or feet or whatever, but it's square root of 73 units long. So my question is, what is this side here? This green side. Well, how did we do this type of problem last time? We should figure out what sides we're dealing with. Are we dealing with the adjacent and the opposite, the adjacent and the hypotenuse, the opposite and the hypotenuse, and then we'll know which trig functions we should be dealing with. So we know this side, this pink side, and this pink side, it should be almost second nature by now, is the hypotenuse, right? It's the longest side, and it's opposite the right angle. So we know the hypotenuse, and what are we solving for? Well, this is the angle we know, so we're solving for the opposite side. So we're solving for the opposite side, and we know the hypotenuse. So what trig function will we probably use? Let's write out our mnemonic. So, ka, toa. So what did I say before? We're solving for the opposite side, and we know the hypotenuse. So we are going to use the opposite and the hypotenuse. So which of these is that? The opposite and the hypotenuse, the O and the H. Right, it's so. Right? And so says that sine is equal to the opposite over the hypotenuse. Sine of an angle, in this case, it's this angle, sine of 0.36 radians. Remember, this is radians we're dealing with, not degrees, is equal to the opposite side. And the opposite side is this green side right here, so I'll just write opposite instead of writing O, because O would look like a 0, is equal to the opposite side over the hypotenuse. Right? This is just sine is equal to opposite over hypotenuse. Well, what's the hypotenuse length? What's square root of 73? Square root of 73. These are p's, by the way. I know they don't look like p's, but opposite for opposite. So the opposite side, we're just multiplying both sides by the square root of 73, is equal to the square root of 73 times the sine of 0.36 radians. Now, once again, I don't know what the sine of 0.36 radians is in my head, but I'll tell you the answer. The sine of 0.36 radians is equal to, I'm just rewriting this, the sine of 0.36 radians, if you looked it up on a table or if you used your calculator in radian mode, is 3 square roots of 73 over 73. And of course, your calculator is going to give you something, it'll give you some decimal number. It won't write it this way. But so just remember, this is this. And I just looked that up. There's no magic there. And the square root of, or you could use a calculator. On the Khan Academy, when you do problems, it'll actually tell you what it is, so you don't have to use a calculator. So now we just simplify. Square root of 73 times the square root of 73 is 73, which over 73 is equal to 1. So these all cancel out. And we get the answer of 3. So this side right here is 3. And just out of curiosity, if you wanted to solve for this side, there's two ways we could do it, right? We could use the Pythagorean theorem, because, a squared plus b squared is equal to c squared. Or we could use trigonometry. I'll let you guess what trig function. Actually, let's do that. Let's use it. Let's figure out that side using trigonometry, and then let's use that side. Figure out that side using the Pythagorean theorem, just to show you that everything fits together in math. So I wrote that 3 there, so I can erase all of this stuff. Let me erase it. I shouldn't have erased it to SOHCAHTOA. Actually, we should have that memorized by now. SOHCAHTOA. SOHCAHTOA. Alright, so let's figure out what this orange side is here. And if you think about it, we could do it a bunch of ways. We could say, well, this is the adjacent side, right? Because we know the opposite and we know the hypotenuse. So we could either use, we know the opposites. We could say, what trig function uses the opposite and the adjacent? Well, that's the tangent function, right? So we could say tangent of 0.36. Let's call this side A, right? A for adjacent. Tangent of 0.36 is equal to the opposite 3 over the adjacent over A. Is there another trigonometry way we could think about this? Well, we also know the hypotenuse. What trig function uses the hypotenuse and the adjacent? Well, if you remember, SOHCAHTOA. Cosine is adjacent over hypotenuse. So we could say cosine of 0.36 is equal to adjacent over square root of 73. I'll just write SOHCAHTOA here just so you can confirm that what I'm doing. Right? That TOA says the tangent is equal to the opposite 3 over the adjacent, and CA tells us the cosine is equal to the adjacent over the hypotenuse. So we could solve either one of these. If we use the second formula, we would get the adjacent side is equal to the square root of 73 times the cosine of 0.36. And then if you use your calculator in radian mode, or I'll just tell you that cosine of 0.36 radians is equal to 8 square roots of 73 over 73. And you could confirm that by getting a decimal number and then making sure once again your calculator is not in degree mode but in radian mode. I think that's actually the default mode in a lot of calculators. And solving for this, but once again the 73, this 73, square root of 73 times this square root of 73 is equal to 73. And then divided by 73, these all cancel out. How convenient, huh? And you get 8. So the adjacent side is equal to 8. And so if we'd solved for A here using the tangent function, we should have also gotten the adjacent side is equal to 8. And just to show you that everything works out from other concepts, let me show you this using the Pythagorean theorem. So 8 squared plus 3 squared should equal the hypotenuse squared, square root of 73 squared. Well, 8 squared, 64, plus 9 should equal, what's the square root of 73 squared? Right, it's 73. And of course, 64 plus 9 is 73. And sure enough, that equals 73, so it works. Isn't that interesting? How math just kind of fits together. I think at this point you're ready to try the modules, the trigonometry 2 modules, and I guess let me know if you have any problems or if you want to see more videos. Have fun.